In this video for section 3.4, we're going to continue with the rational zero theorem. And we talked earlier about how to list possible zeros for the function. Now we're going to determine which of these are actual zeros of the function. And we do that by using synthetic division on the possibilities, looking for a remainder of 0. Once we find one that has a remainder of 0, that is an actual zero. If it doesn't have a remainder of 0, then it's not a zero of the function. Once we find one that works, then we set the result of the synthetic division equal to 0 and solve to find the other zeros. So again, the key idea here is we're looking for a remainder of 0. So we're going to do example 3 here from the textbook. These are one of the more complicated problems that we're going to see in this class. And my first step when I'm doing this problem is to find the possible zeros. So I do factors of the constant, which is -6, divided by factors of the leading coefficient, which is 1. Factors of -6 include 1 and 6 and 2 and 3. And we put plus minus on each because they could be positive or negative. My factors of 1 are just plus and minus 1. So if I divide each of these, I get positive and -1, positive and -2, positive and -3, and positive and -6 as my possible rational zeros. So there are 8 possibilities. Now what I need to do is just pick one of them. I'm going to start by picking +1 and do synthetic division using my coefficients of my polynomial here. So this is going to be 1, 2, -5, and -6. And then I need to see what the remainder is. So I'm looking for a remainder of 0. So I'm going to run through this. And I get a remainder of -8. So that's not 0, so that means it doesn't work. So 1 is not a 0 of the function. Next, let's try +2. So same coefficients here. There's really no shortcut way to do this. You just have to test possibilities until you find one that works. So this one, -6 plus 6, is 0. So that worked out. That means that 2, the number that I had in the box here, is a 0 of the polynomial. And that also gives me something that I can solve to find the other zeros. So I'm going to set this back up into the answer here. That's x² plus 4x plus 3. Remember, the number second to the left is the constant. Next we have in front of x, and next we have in front of x². Set that equal to 0 and solve it to find the other zeros. So what I want to do when I'm solving is first ask if this can be factored. So are there two numbers that multiply to 3 and add to 4? Yes, they would be 3 and 1. So I can factor this into x plus 3 times x plus 1. If it can be factored, you want to do that because that's generally the easiest way to solve it. Set each factor equal to 0. X plus 3 equals 0 gives me a solution of -3. Subtract 3 from both sides. X plus 1 equals 0 gives me a solution of -1. Subtract 1 from both sides. So I have 3 answers here altogether. The 2 that I found originally, this 2 from my synthetic division, and these 2 answers, -3 and -1. So I would put all of those in the squiggly bracket. Those are my 3 solutions. So next you should look at checkpoint problem number 3. Do this in your notes, check your answer, and then move on with the video. Next, we're going to look at example 4. So I'm going to start in the same way by finding my possible zeros. So I need factors of the constant, which is -3, divided by factors of the leading coefficient, which is 1. So factors of -3, the only possibilities are 1 and 3. Factors of 1, the only possibilities are plus or minus 1. So my possible zeros are plus or minus 1 and plus or minus 3. So there's only 4 possibilities for this one, which is nice. Less that I have to test. I'm going to start by trying negative 3. And my coefficients are going to be 1, 7, 11, and negative 3. Go through my synthetic division here. And this one is going to work because I got 0 for a remainder. So negative 3 is one of my zeros. So I have my result here, and when I put that into polynomial form, it's x squared plus 4x minus 1. And I want to set that equal to 0 and solve. Now for this one, I can't solve it by factoring, unfortunately, because there are no numbers that multiply to negative 1 and add to 4. So that means I need to either use the quadratic formula or completing the square. In the notes, I show how to do it using the quadratic formula. Now I'm going to show you how to do it using completing the square. You can use either method here because I don't have a number in front of x squared and my value for b is positive. So use whichever method you find easiest. So if I'm using completing the square, I need to move the constant over first, and then I need to calculate b divided by 2 squared. So 4 divided by 2 squared is 2 squared, which is 4. I add that to both sides, and that gives me x squared plus 4x plus 4 equals 5. Now I factor the left-hand side. That's x plus 2 times x plus 2, or x plus 2 squared. Get rid of the square by taking the square root of both sides, and don't forget plus or minus. So we have x plus 2 equals plus or minus square root of 5. And lastly, I subtract 2 from both sides to get x by itself. So negative 2 plus or minus square root of 5. So this actually represents two solutions. One of them is negative 2 plus square root of 5, and one of them is negative 2 minus square root of 5. And you can enter them separately, or you can enter them together using the plus or minus symbol in MyLab Math. My third solution is this negative 3 that I found up here. So what I would type into the squiggly bracket is negative 3, comma, negative 2 plus minus square root of 5. And those are my solutions. So next you should look at checkpoint problem number 4. Do this in your notes, check your answer, and then move on with the video. I'm going to do one more example here in this video. This is exercise 19 from the homework, and you're going to see a similar problem in your homework assignment. So we have the equation x to the third minus 10x minus 12 equals 0. And our first part of the problem is to list all rational roots. Now this problem is written a little differently because it's already set equal to 0 instead of being a function. And they're asking me for roots instead of zeros, but it's essentially the same thing. So don't let that throw you off. So my possible rational roots, I'm going to do factors of the constant, which is negative 12, divided by factors of the leading coefficient, which is 1. Now, negative 12 has several factors, 1 and 12, 2 and 6, and 3 and 4. Luckily, 1 only has 2 possible factors. It's got to be plus or minus 1. So altogether here, my possible factors are positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 4, positive and negative 6, and positive and negative 12. So there are 12 total possibilities. Now I'm going to use synthetic division to test them in order to find one that works. I'm going to start with -2. And when I'm listing my coefficients here, I need to remember that because there is no x squared term, I need to put a 0 in that place. So it's going to be 1, 0, -10, and -12. If you don't have those listed correctly, then the synthetic division is not going to work and you're not going to get the problem right. So go through synthetic division here. And this one is going to work out on my first try. So that was lucky. So this tells me, since I got 0 for a remainder, that -2 is a solution, or is a root, is the wording in this problem. So the way that this is set up in the homework is going to be exactly the same as this. For part B, you're just going to enter the root that you find using synthetic division. So I would type in -2. And then question C says to use the root from part B to solve the equation. So what I'm actually using is the result of the synthetic division there. So that's going to be x squared minus 2x minus 6. Set that equal to 0 and solve. Now this is another one where I can't factor this because there are no two numbers that multiply to -6 and add to -2. So I need to use completing the square or the quadratic formula. Since I did the other one with completing the square, I'll use the quadratic formula here. It doesn't matter. Completing the square would work too because I have a even number in front of x and I have no number in front of x squared. So, but I'll use the quadratic formula. Again, just pick the method that works for you. So we have -b, which is going to be +2, since b is -2, plus minus square root of b squared minus 4 times a times c, all divided by 2a. -2 squared is 4, and 4 times 1 times -6, that's going to be +24. So we have 2 plus or minus square root of 28 over 2. And now I need to think about if I can simplify my square root. In this case I can, because square root of 28 is the square root of 4 times 7. So that's going to simplify to 2 times square root of 7. And now, looking at the three numbers, they're all 2's, so they all can be divided by 2, which means I can change them all to 1. Now, when I'm writing this, this 1 I need here. I don't need the 1 in front of the square root of 7 because 1 times anything is itself, and I don't need the 1 in the denominator because anything divided by 1 is itself. So this would be my answer, 1 plus or minus square root of 7. So I'm going to put that in the bracket along with my other answer that I found up here, which was -2. So 1 plus or minus square root of 7 and -2, those are my solutions. So now you should do the homework problems for this section.